celestial eclipse, we could land up with that full blood, really reddish hue. And that's exactly what we're going to see over the coming hours. So by my reckoning anyway, this makes it a mini buck blood moon total lunar eclipse. So if I remember that 2 hours into the show, we'll be very lucky. Anyway, we have got full coverage with live streams of the entire event here at Slooh, and we've got 3 hosts who are going to be coming on air at intervals to keep you entertained and informed, hopefully. So sit back, enjoy the live views, and enjoy this very special event with Slooh. And make sure you watch over at slooh.com in what we call the Situation Room, where you're going to be able to snap your own images from the live streams as they come online. And they are going to be coming online in succession tonight. So but anyway, listen, presumably, if you're here, you kind of enjoy this kind of thing. And if you do, please consider joining Slooh as an apprentice member or an astronomer member to support our mission to teach the world to explore space. You get to watch live views of the sun, the moon, the planets, galaxies, nebulae, star clusters, constellations, supernovae, and just about every other celestial object in the night sky. And you see those through Slooh's online robotic telescopes that actually you can control from the comfort of your own armchair. And you can also follow our various courses and live casts about astronomy each week as well. So not only that, but you also get to do all of that stuff in our wonderful worldwide community, kind of all learning to explore space together. But anyway, listen, back to today's celestial event. The eclipse is due to commence 14 minutes past the hour. While we wait for that, though, to help set the scene for our mini buck blood moon total lunar eclipse, please welcome Slooh astronomer Dr. Paige Godfrey to the show. Hey, Paige. We can't hear you. Are you muted?
Yes. I was muted waiting in the wings, and just this is what I said last night. I told everybody who was watching the Mars opposition live cast that if it weren't for Paul Cox, I would lose my head. And here we are again.
Paige, so before we jump into this, let's ask the studio to see if we can get our first glimpse of the moon. I know we've got Cos Corneas on with his live feed from South Africa. I've just spoken to him. There it is, coming up. A little bit of buffering with that, but don't worry, it'll soon get better over the course of all of this. And as you can see, Paige, we've got no lunar eclipse yet. No difference to a normal full moon. But anyway, you know, how are you anyway, Paige? You looking forward to tonight?
Absolutely. I'm really excited. Now, I mean, I was there for the one in January, and it was incredible. That was the first one I had seen.
So, oh, really? Okay, so this is going to be a really, really cool one, I think. And I kind of have the benefit, we're going to tell people where this is visible from and stuff like that, if they can see it with their own eyes. And I'm quite fortunate. I'm in the UK. I'm just on the outer edge of where we can see the total lunar phase of the eclipse, which is when it's really red. But that's just as the sun, as the moon rises. But anyway, Paige, we're going to get into what is a total eclipse and stuff like that in a second. But if our viewers want to ask us any questions or post their favorite eclipse images that they've snapped from the live feeds, or even just tell us where they're viewing the live cast from, how do they get to do that?
On social media. So on our Facebook and our Twitter, we'll be monitoring during this entire live broadcast. So you can tag us at Slooh and hashtag Slooh, and we will find your questions.
Radio. So we want to also hear, if you haven't got any questions, then we want to hear where you're watching us from, because it really is a global community. So Paige, what are we going to kick off with?
All right. What is a total lunar eclipse?
Oh, okay.
I think we should just start with the definition of it.
I think that's pretty good, isn't it? So we kind of all know that these 3 bodies, we've already seen 2 of them, and we're sitting on the 3rd body that creates this total lunar eclipse. We've got some great graphics, actually, that we can show that really explain this as we kind of go along. But basically what we're seeing here is there's the sun on the left, there's the moon and the Earth. So we've got the moon orbiting Earth, and sometimes that happens. So the moon passes into these two different types of shadows that the Earth forms. The penumbral, which is the outer shadow, but also there's a kind of far denser one, which is called the umbral shadow. Now, we're going to be talking about these throughout the entire event. So what we're going to see to start off with here, Paige, is kind of the penumbral stage, and then it's going to go, isn't it, into the umbral stage, which is when we start seeing some glorious color. That's exactly when that kind of thing happens. Now, we've got another one as well, I think, another animation maybe that we can pull up. But Paige, where can we, while we're talking about the exact phenomena, where can people see this eclipse from? Where is it visible?
So it's not visible in the United States, which is why we're fortunate to have feeds like this available to us. But it will be available in South America, Europe, Africa, Asia, and Australia. So here is a visibility map of where you would be able to see it if you have clear skies.
Yeah. So there we see the dark bit obviously is nighttime. We see the moon right in the middle of that because it's a full moon. You know, it's bang smack in the middle of the night kind of thing overhead. And there we can see where it's going to be going red and stuff like that. But if we hop back to that previous diagram we showed, we can see quite clearly here. There it is. So there are those two shadows. Looks like a kind of bullseye there. And we can see the moon there kind of traveling across, first of all, into that outer kind of black ring. So that's the penumbral shadow. And all we're going to see there is this kind of bit of darkening, but it's when it goes into that central umbral shadow, that's when things start getting pretty exciting. But yeah, what else have we got, Paige, on this?
Is
Just
that
looking.
when the color changes?
Yes, it is, and this is the exciting. This is always actually the really exciting thing about a lunar eclipse, because all lunar eclipses are very different. So we might see pink tonight, we might see peachy, we might see red. Now, a lot of that stuff, it also changes, doesn't it, Paige? Depending on things like the atmosphere as well,
Mm-hmm.
and there's a reason why this one should be a lot redder, I think, than a lot of maybe the lunar eclipse that we saw earlier on the year, which was kind of far shorter, wasn't it?
Right. So this lunar eclipse is particularly long because we are experiencing a mini moon. So the moon is at its furthest point away from Earth. And so as it orbits Earth, it's going to slow down. The speed with which it orbits increases
Okay.
when it's closer to Earth. And then when it's further away, it goes more slowly. And so because it's moving more slowly, it's going to take longer to go through the shadow. So this gives the
Okay.
time for the sunlight to go through more of Earth's atmosphere, to be more heavily reflected on an angle back to Earth, and then that's what creates the color variation.
Okay, so that's really interesting, because there's one effect there. So we're talking about this mini moon, and you're going to do a whole segment, I think, about what's the
Mhm.
differences between a mini moon and a super moon. But if we go back to that diagram again, the other reason why this is so long, and also why it should be, you know, quite an intense color, is it depend. You can have a total lunar eclipse, one at the beginning of the year, just skirted the that umbral dark shadow, Earth's inner shadow in the center of that. This one, you can see the path that the moon takes through that shadow from Earth is really pretty close to center. So you can see if it's on the edge, it's not going to last very long, the actual total phase. But if it's going close to the center, which it's doing tonight, then
Right.
it lasts a lot longer. And because it's buried deep in the heart of that umbral shadow, that's when we can get the most extreme color. Actually, we've got a great thing, haven't we, Paige, to show viewers about what this would look like from for an astronaut if he was on the moon, because I've always wondered this.
Right. So essentially, what's happening is that the Earth is blocking the sunlight from reaching the moon. So as you can see in this depiction, if you were standing on the moon, the sunlight is not going to reach you. Earth is blocking it. So you're seeing basically a total solar eclipse from the moon via the
Excellent.
Earth getting in the way.
And there we can see as well, actually, one of the other kind of effects, and one of the things that we're going to talk about later, we could see there that as the sun, in fact, we might have another cool little animation to show people about the color, what causes the color. We saw when the Earth got between the sun and the moon, Earth's atmosphere kind of went red. And here we go. So this is how the light is scattered by Earth's atmosphere. And red is the one that gets bent most, isn't it, Paige?
Yes. So
So
this is a whole lesson on why sunsets turn red. Red light is longer wavelengths than blue light, and so they are scattered. As the light enters the Earth, the blue light gets scattered away. So when the sun is overhead, our sky is blue. But as the sun is setting, it has to go through more atmosphere. So the blue light is all scattered away, and you're left with the longer red wavelengths coming through.
okay,
So
and
this
that's
is
what's
what
being,
is causing,
yeah. So that's we can see it there. That all that red wavelength light is being focused right into the very heart of that umbral shadow, and that's again why the closer the moon gets to the center point of that umbral shadow, the redder it normally is, because it's the most extreme red light that's being bent towards it. So I'm really looking forward to this one, Paige, I have to say. Oh, look at the countdown clock, Paige. We have got
there we go.
35 seconds. Now, don't expect anything absolutely astonishing to happen in these first minutes, because imagine what's happening at the moment. In fact, Paige, you tell us what's actually happening at the moment with the moon in 17 seconds time.
So in 17 seconds time, the partial part of the eclipse is starting. So it's going to go enter the penumbral phase. So it's just going to be a light shadow. This whole feed, the whole eclipse is going to take about 6 hours. So we're really just hitting the tip of the iceberg right now. But this is the moment where it's starting.
And some people say, in fact, some people even in Slooh say that the penumbral phase of an eclipse is not worth looking at. But I really have to disagree, and you only have to go back through the tens of lunar eclipses that we've covered at Slooh over the last 13 or 14 years or whatever, to know that we will see a very specific darkening during this penumbral phase. Now, if we carry on watching this particular feed, or any of the others, if they, as soon as they come online, we will see very clearly a kind of darkening, a little notch first of all. It doesn't go kind of jet black, it's not like a solar eclipse, but it's a little kind of darkening of the moon, and then that gradually will swallow up more and more of the moon. And when it kind of covers the whole moon, that's when the moon starts to enter the central phase, and that's when we start seeing color added in to that mix as well. So plenty to look forward to, I think. I'm really looking forward to this.
We have someone on Twitter just let us know that they're watching from Tacoma, Washington State. It's Colette Babson. Hi, Colette.
Hi, Colette. Welcome.
Remember
hopefully,
announce
go on,
to
Paige.
us where you're watching from.
Exactly. And hopefully everybody has kind of bedded down here. You know, you've got plenty of eclipse watching snacks. I've got water, unfortunately, no alcohol at the moment, but that will flow at some point later. But plenty of snacks, because get in here for the long haul. And, you know, we haven't actually said it yet, but what we're going to be doing is we're going to be coming on and off with hosting sessions. So I'm going to be on, Paige is going to be on, Helen Avery's going to be on. And in between that, you can carry on watching all of our live feeds as they come online, and just enjoy some music. We got some fascinating factoids and stuff like that coming up as well. But Paige, have we got anything else to talk about as far as what people are going to see tonight.
Yeah. So, what can they expect to see in the live feeds, and where are we getting our live feeds from? That's a question I had leading up to this a lot, actually, is where are we getting these feeds from?
Ah, okay. So we have got them from um, the first one, which hopefully should be coming online, that one in about 40 minutes time. That's going to be from the Sharjah Center for Astronomy and Space Sciences. That's the Emirates of Sharjah in the United Arab Emirates. We've got Kos Coroneos in South Africa, who's providing this feed. He very kindly got this feed up and running really quickly. We've got to keep our eyes open for this to make sure that we've got a bit of buffering on that. So the studio might want to just refresh that because we should start seeing a little bit of a shading on there. We've also got Keith Cobby from F4 Astronomy live in the desert of the United Arab Emirates. So they're right out in the desert, and they're going to be providing us a great feed, hopefully, from there. Because sometimes they get a bit of a dusty atmosphere, we may see some really extreme color, because that's the other factor that does affect how much, how red the moon gets, and that's the status of the atmosphere. So if we've had a lot of fires, if there's been volcanic atmosphere, if it's a particularly dusty place like the Middle East, then just that extra dust in the sky can kind of add on this extra level of richness to the color. So, but we've also gone as far afield as we've got Jonathan Bradshaw from the Samford Valley Observatory in Australia. And a little bit later on, we might be pulling in some feeds from our friends over at Time and Date as well. So we've got plenty of feeds coming in. And here we've got Paige. This is looking at our flagship observatory in the Canary Islands. Now, what we can see here is all of the big professional domes there with some of the largest telescopes in the world. This is on top of a volcano, 8,000 feet up in the sky. So we're above the clouds, you can see it there. And what we're seeing there in the sky is the sun. But the sun is about an hour and a half away from setting. And don't forget that with a full moon rises as the sun is setting because they're in opposite sides of the Earth, so opposite sides in the sky. So we are also going to have the very telescopes that Slooh members use every night watching this eclipse as it rises. So it's going to be rising in the Canary Islands fully eclipsed. So that's going to be quite a good one to have a look at, I think.
Since we have feeds from all over the world, I think it's appropriate to shout out all the people we have around the world that are watching. So we have Carolyn on Twitter, is from Washington, D.C. Mona Alta didn't mention where she's from, but she said she's watching while working. Good for you.
Okay, yeah, absolutely.
We have Vitana Taka is watching from California. And then there's a whole list coming from Facebook where people are. So we have Stockholm, Argentina, Colombia, Sri Lanka, Venezuela, Malaysia, Japan, Brazil, Richmond, Virginia. I mean, it is just a huge list. We might be covering every state in the world.
Exactly. And in that mix, there were people who are lucky enough to be able to see the total lunar eclipse in their own sky. So a lot of those people in the far East, Japan, India as well, and actually South Africa as well, and a lot of the African countries. But also, of course, you mentioned some of those poor folks like you over in the USA who are not going to get to see any of this eclipse, are you?
Well, it's a good thing I can watch while working too, since this is my job.
Good one. Hey, listen, Paige, this is a view that I'm really looking forward to a little bit later on. In fact, that's going to be in about, let me do the calculation on that. It's going to be in about 4 hours time, I think. What we're going to see, this is a camera right on top of the volcano, which is actually another 2,000 feet above us, 2,000 feet above the observatory. So the observatory where all the domes are, which we were looking at, are kind of right down on that ridge. But you can see there we're right above the clouds. But the volcanic cone on the island of Tenerife is incredibly, it's almost a perfect pyramid shape. And what it does is it casts a shadow. And it's going to be casting a shadow right over there across the island over the sea, over the Atlantic Sea, over to the neighboring
Wow.
island of Gran Canaria. And because the sun is setting behind us and the moon is rising in front of us, that great big pointer is going to be pointing to exactly where the fully eclipsed moon, the total eclipsed moon, is rising above the sky there. So I'm really looking forward to that shot a little bit later on.
Well, now you have us all looking forward to it too.
Exactly. Now, listen, Paige, I guess we ought to kind of wrap up this first little bit. In fact, let's just take a quick look at the South African feed. We are expecting the others to come online soon, so we should start. Maybe the studio can refresh that. They haven't. It's not going to stop buffering that one, I'm hearing. So we will keep going on that one, but I'm just checking to see if the United Arab Emirates or Australia are coming online, and I am being told here that they are going to be online very, very shortly. So we need to keep an eye. If you're
Great.
watching at slooh.com, underneath the video panel where you're watching us now, you can skip along there, little tabs there, and we've got the other feeds that are in there. So when those images start coming in, you'll be able to click on those and you'll be able to snap an image and share that with anyone that you like. But I think it's probably time that we kind of jumped off here, Paige, and let viewers kind of chill, relax, maybe go off, get those snacks with the live feeds, some music I think we've got, and some fascinating moon facts. But what have we got coming up in the live broadcast page for the rest of this evening?
So we are going to have Slooh storyteller Helen Avery on in just about 20 minutes. She's going to talk about lunar eclipses through the ages, what it means to our ancestors. And then spotted throughout the rest of the day is going to be me, you, and Helen coming on at various times, together in solo, to keep watching the feed, marking the important moments, like when it starts the umbral phase and during the maximum totality. I'm going to be talking a little bit about supermoons versus mini moons, tides, maybe the Mars opposition.
Yes,
Paul,
of
what are you
course.
going to be talking about?
At 20 minutes past the next hour, so in an hour and 5 minutes, I'm going to be back to mark the beginning of that umbral phase of the eclipse, and that's when we'll start to see the moon start to change color, take on, it'll start off pink or peachy, and then hopefully, I'm really crossing fingers for this one, that this is going to be, you know, it's actually, I haven't seen a lot of the press calling this one a blood moon. The press and media usually
No.
go mad about calling it a blood moon. And all of those lunar eclipses that we've had over the last few years have been quite subtle as far as colors concerned. So they've called them a blood moon, but actually they turned out to be quite pink. So I'm kind of really hoping that this one, where nobody's calling it a blood moon, it actually turns out to be a blood moon. So that's what I'm going to
It's
be
one of our
talking
best
about.
chances.
It is absolutely. It was such a deep eclipse. And don't forget, folks out there, if you want to ask Paige, myself, or Helen Avery any questions, or you just want to tell us where you're viewing us from tonight, or I keep saying tonight, I mean, it's early evening here in the UK. It's early afternoon for you, Paige. I know, dear Jonathan Bradshaw in Australia giving us his feed there. It's really late for him. This is happening in the hours before dawn. So it's different for everybody. But anyway, for now then, Paige, I guess we ought to get our viewers to sit back and enjoy the music and our live feeds. And don't forget to snap and share your own images from our feeds if you're watching at slooh.com. So from Paige and I at the moment, we'll see you a bit later. Helen Avery is going to be on in about 20 minutes time. Don't miss that. She's going to be telling us about lunar eclipse through the ages and what they meant to our ancestors. So goodbye for now.
Good morning, good afternoon, good evening, wherever you are in the world. Welcome to Slooh. And we are here with you as we watch the total lunar eclipse. It's not a total lunar eclipse everywhere in the world, but it is a total lunar eclipse if you are in Australia and parts of, in Asia and Africa and the Middle East. And as you can see, we're looking right now at one of our feeds from Australia. This is sort of pre-eclipse. It's going to be one of is in fact the longest eclipse of this century. So if you're feeling a bit odd today, I know I am, then we can blame this really, really long eclipse, and we're going to be here with you for the duration. So I'm going to be talking for the next, 10, 20 minutes or so about how the lunar eclipses used to be seen by humans. Now today, if you are watching the lunar eclipse with friends or on your own, we tend to sort of have a very scientific-based approach to how to view the lunar eclipse. But this was not, of course, the case for ancient peoples. So how did they see a lunar eclipse? Chiefly, much in the way they saw a solar eclipse, they believed that something was eating the moon. And that this was also the reason that the moon turned like a blood color, a red color, as it was sort of spilling blood as it was being devoured. And you can find this belief across cultures and across the world, and it's kind of obvious, sort of why. If you think sort of the biggest human terror, sort of the one that we can protect ourselves against, really was sort of ferocious animals and being eaten. So when we start to see the moon disappear, it's kind of logical that we would jump to the conclusion that the moon is also being eaten. And in fact, the word for eclipse in Chinese is shi, which means to eat. But depending on where you are, depends what kind of character was eating the moon. So to the Incas, they saw a lunar eclipse as a jaguar taking a big munch out of the moon. In parts of Brazil, it was seen as a frog. In China, a dragon, as you may imagine. To the Hindus, it was a demon called Raku that came around every eclipse, in fact, and wreaked havoc. It was the eclipse demon, was Raku. To the Nordics, again, as you might imagine, sort of using sort of taking the animals that were around them in their culture, it was a wolf that was seen devouring the moon. And also in parts of Germany, also a wolf. So what did they do to try and stop it? And obviously they believed that it was working, whatever they were doing, because the moon would pop out again and there it would be the next night too. So it was kind of one of those things where they would believe that if they could frighten away whatever was eating the moon, that it worked. And so next time they did it again and again and again. So it became a tradition, and they truly believed that it was what they were doing that was frightening this animal away or this demon away. So what did they do? So for the Incas and the jaguar eating the moon, they would raise their spears and throw them towards the sky with a lot of hollering and shouting. The same for the Brazilians and the large sort of tree frog that was eating the moon. The Chinese, to scare away the dragon, would bang pots and pans and also parade through the streets. And the Mesopotamians took it a little step further. They believed that lunar eclipses brought utter chaos and destruction. So their way of kind of getting around it wasn't to fight whatever was attacking the moon, but it was instead sort of a way of defense. They believed that during a lunar eclipse, you could lose your king and you could lose your armies. And so what they did was, during a lunar eclipse, they replaced the king with a surrogate king. So what would happen is they would ask for volunteers, or they would look around at who maybe had their eye on the throne, or the king might decide who had their eye on the throne, and he would make them a surrogate for the period of the eclipse, during which they could do whatever they wanted truly as king. And then when the eclipse was over and all was safe, this poor unsuspecting fool would then be done away with, typically poisoned, I'm told. So that was one way of dealing with it, but at least someone got to be king for a day, I guess. The Babylonians would go out into the street again with parades and create altars, and offer sacrifices to whatever it was that was eating the moon to get them to go away. Sort of a bit less aggressive on the side of not throwing spears and trying to kill whatever it was. But some of the North American tribes early on would recite prayers to the moon, chant to the moon, sing to the moon. Fire in a lot of cultures was considered as sort of that it would be able to counteract whatever it was that was attacking the moon. So a lot of people lit fires and prayed round fires. The Romans even paraded through streets with torches and through like firecrackers, oldie firecrackers at the moon to get whatever it was there that was going away. So lots of fun stuff that obviously today we sort of realize that it's nothing eating the moon at all, but it doesn't stop us going out and chanting and whooping and hollering, because of course every lunar eclipse comes with a full moon that we'll be talking about a little bit later. One interesting thing I wanted to talk about was this the link between the dragon and the eclipses. So I'm just going to read something that is in a really wonderful book called The Moon, just because it says it better than me. So remember I mentioned that Rahu was considered this eclipse dragon by the Hindus, and actually it was sort of his head was sort of part of one eclipse, and then his tail was part of another eclipse. And it was called the eclipse sort of demon, rather, which actually means the ascending node of the moon. So the ascending node of the moon is like the time, the nodes are like the points where the moon crosses, in its orbit crosses the ecliptic. That's the plane of the Earth's orbit around the sun. And the time taken by the moon to circle back to the same node is actually called a draconic month. Sort of taken from the Greek drakon, which means dragon. So even today, we call this cycle from lunar eclipse to lunar eclipse a draconic month. So the dragon is sort of inbuilt in it. And even in Europe, this ascending node of the moon is still known as the dragon's hair, sort of taken from the sort of Indian mythology of this demon who looked like a sort of dragon as well. So it's really interesting to me that that we sort of have this ancient idea of eclipses being brought to us by celestial dragons, and it's something that we still sort of have in our language today. But there are a few, as to whether lunar eclipses do result in disasters, there are a few accounts through the ages, and I thought I'd just read a couple of them to see what you think. I mean, I'm sort of just mind blown that we have records of lunar eclipses. One dates back as far as over 3,000 years ago, and it was sort of the first mention of a lunar eclipse that we have, and it was in the Chinese book Zhu, the book of the Shu dynasty. And although it was discovered in 280 AD, it was actually thought that it was written in about 1100 BCE. And it was found in this tomb of noblemen, and it just describes the lunar eclipse that took place. So it's sort of very, obvious, and it seems obvious when you think when we had only light to go by of sun and moon, that of course we would be sort of hyper aware of what was happening to the moon. Today, I'm sure there are people, if we're out there and ask them, do they know it's a lunar eclipse today, they'll have no clue at all. But I know that plenty of us do, because I was looking at Facebook, and I know there are people here from all over the world, from Southeast Asia and Indonesia and all across America and Colombia and Mexico and Argentina and throughout Europe, and obviously Australia. So it's lovely that we are sort of taking note of this lunar eclipse, even though we're a little bit more out of touch of nature these days. One of the interesting times that this a lunar eclipse was noted was in it was also sort of BCE 413 BC on the 28th of August, and it happened during the Second Battle of Syracuse. So just as the Athenians were preparing to sail home, there was this lunar eclipse, and it was described, people didn't know what to do. They were quite superstitious. What should we do? We're sailing home, there's this lunar eclipse, and the priest advised them to just wait for a whole another moon cycle before they went back home. But what happened was that the enemy, the Syracusans, took advantage of this and attacked them, and they were completely defeated, and many were killed, sadly. So it was a bad lunar eclipse for the Athenians, although not for the Syracusans. So two sides to every story, I guess. The other one was there was a partial lunar eclipse seen in the fall of Constantinople. That was the capture of the capital of the Byzantine Empire. And then one of the most well-known tales of a lunar eclipse, it was about controversial figure Christopher Columbus. And it said that he was stranded in Jamaica in 1503, and the people there were very kind and fed him and helped the people he was with. But after 6 months, the natives to Jamaica were kind of tired of Columbus's people taking their food and giving nothing in return. So they stopped giving them any more food. Now, Christopher Columbus had a book. It was the Regiomontanus. It was an almanac of astronomical tables, and he knew there was going to be a lunar eclipse. So, sly devil that he was, he told the people of Jamaica who'd been helping him that they would be severely punished if they didn't start feeding them again, and they would know because the moon would disappear. So what happened was that he knew exactly what time to start pointing up, and he showed the people, the native peoples of Jamaica who were there at the time, the moon, and obviously they believed him that he had this power and that they were going to die, because obviously Christopher Columbus must have been a god if he was going to get rid of the moon. And he even knew, it said, the exact time that it would end. So he said to them, you have exactly this amount of minutes in which to go and get your food and feed us. And it said that they did just that. So, like him or loathe him, that is the story of Christopher Columbus and the lunar eclipse. So we're just still enjoying these wonderful images of our moon, and we have images throughout the next few hours as we're showing you sort of live feeds from wherever the lunar eclipse is happening. I'm going to be back a bit later to talk about, okay, this is how the ancients saw the lunar eclipse, but what does it mean to us today beyond sort of the scientific element? Sort of, what does it mean to see the Earth's shadow? Do we ever even think about the Earth in these ways? So I'm going to be talking a little bit about that and touching on a little bit more of the hocus pocus stuff that we normally avoid here at Slooh about sort of, what does it mean astrologically? And then also whether there's sort of any truth to increases in seismic activity happening around a lunar eclipse. So we're touching on those later, and then also talking about this particular moon and what it means. This particular full moon, it's known as the buck moon, but it also
Hello and welcome to Slooh, where you are learning to explore space. Hopefully you're doing the same as I am, having a nice cup of tea or eating your snacks or anything else like that, because we're in it for the long haul today with this lunar eclipse. Take my last slurp. Anyway, I'm Paul Cox and you're watching Slooh's live coverage of the mini buck blood moon total lunar eclipse. Where else can you see all of those things in one go? Now, look at this live feed coming in from Australia. This is Jonathan Bradshaw at the Sanford Valley Observatory. And if anybody ever told you, oh, you can't see anything in the penumbral phases of an eclipse, there is the proof that they are wrong. We're right. There you go. Anyway, doesn't that look great? So this is, if you've just joined us, this is the penumbral phase, but we're just about to move actually in... There's our countdown clock. We are now entering the umbral phase of the moon. This is where the moon's edge is starting to go into that inner part. We'll pull up the graphic for this actually, because we've got these two shadows that we've been looking at. And so far, the moon has kind of been edging its way into the outer shadow. And that's when we start seeing exactly this kind of slow dimming off one edge, and then we see a curve, because that is Earth shadow. So hey, how about you flat earthers out there, why don't you explain this one away, that the shadow is curved but you say the Earth is flat? If the Earth was flat and the sun was over there, then it'd just be a straight line, wouldn't it? A shadow. Anyway, try it with a piece of paper. It might make more sense. Anyway, we're going to pull up this diagram because I do want to show you this switch between these two different phases. So here it is. So think about this over on the right hand side. So you see the moon just as it enters that first bullseye circle. So that marks the black circle, really, the black donut, the torus. That really marks the penumbral shadow, the outer shadow cast by Earth. So we've got the sun behind us, we're sitting on Earth, moon in front of us. The moon is passing into Earth's shadow, but the Earth has two shadows, this outer one, and then the really dense one, which it's just starting to enter. So the moment that we're at now is, let's say, the second moon from the right, all right? So the one that's fully in, really, to the torus, and is just about, one edge of it is just about to enter that inner shadow of Earth, which is called the umbral shadow. And this is when we start to see some color. So anyway, let's go back to our live feed. This is we'll move to all of this, I guess, over the next 20 minutes or so. Look at that. So you've got to keep your eyes open for this, because what our feed partners around the world have got to do, and we're going to step through all of the feeds in a sec, is during a lunar eclipse they have to change the exposure levels because the moon is getting darker and darker. So if they kept it at this setting, if they kept all their camera and video gear at these settings, the moon would actually go black. But what they've got to do is they've got to start adjusting now, and it's adjusting every kind of 5 minutes so that we can see the fully illuminated part of the moon still, but also this umbral shadow starting as well. And when we do that, we'll start to see, so in this image from Australia, we're going to start to see some color coming, probably on that left hand side. That's kind of around the 7 or 8 o'clock position on the moon there. So, but we have got some other feeds up as well, so the studio will bring those up, because I know we've got one of our United Arab Emirates partners down there. They've got their feed up and running as well. So, and we've got a couple of others coming online a bit later as well. So anyway, we have got, as I say, the mini buck blood moon total lunar eclipse, but that's not all. This you're watching tonight, you're joining us now for the longest total eclipse of the 21st century, when the moon passes through Earth's shadow as the sun, Earth and moon align in this kind of perfect geometry that causes an eclipse. And we haven't actually explained, you know, if you're looking at these diagrams, in fact we might bring some of those up as well. Look at that, that's a great shot actually from the Sharjah Center for Astronomy and Space Sciences at the Emirate of Sharjah in the United Arab Emirates. Look at that there. I know they've been battling a bit of cloud in the United Arab Emirates, of all places, to get some cloud. But this is turning out to be a pretty cool feed as well. So anyway, we're keeping an eye on that, but I was hoping actually that the studio might be able to bring up some of the earlier animations that we had, because we were explaining to you that a lunar eclipse, a total lunar eclipse, can only occur at a full moon, which it is. Just let's go back to our, so it's opposite the sky to the sun sets in the west, the full moon rises in the east. Well, you might be asking yourself, well, hold on a sec. If the moon is passing through Earth's shadow tonight, why isn't it doing it on every full moon? So there it is. So what we've just seen there is it's just passed where it is now. That is in the umbral shadow. So that's when it's going to be at greatest eclipse. So here we go. So here's the moon orbiting Earth, and we're going to see now the shadows cast, these two shadows cast. There you go, bang. That's what we've been through. That's what we've just gone into. So it's just entered that dense, narrow cone. So why doesn't it do it every single month when there's a full moon? Well, there's a really easy explanation for that. If you imagine the moon's orbit around Earth is inclined at an angle of about 6 degrees, which means that most of the time on a full moon, all but maybe 2, sometimes even 3 lunar eclipses a year, the full moon is passing either above those shadow cones, because that's what they are specific cones. The shadows are specific cones. The moon, I know, passes either above cast, there you go, or below the Earth shadow. So that's why we don't get them every night. And if you can remember, we had one, a lunar eclipse at the beginning of the year. That was a great one, because that was actually a blue moon lunar eclipse, which was pretty cool. And also, Dr. Paige Godfrey is going to come on a little bit later, and she's going to do some more explanation of why this is the longest total lunar eclipse, because there are a few things here, a few factors to take into account that actually cause that. So anyway, studio, I'll go back to some of our live feeds as well. We've been broadcasting, Slooh's been broadcasting these live celestial events for well over a decade now. God, am I really getting that old? Yes, I am. But I've been looking forward actually to this lunar eclipse more than any of the others that we broadcast over the years. And really, one reason the eclipse is so long is that it ventures right into the very heart of Earth's dark umbral shadow. So it takes longer for it to move through that central circle that we were seeing. But the reason why that's kind of making me excited about this particular eclipse is because the deeper it goes into that shadow, the more rich and deeper the color we see should turn out to be later on. So when it's fully immersed, I'll tell you the timings of this a little bit later, but when it is fully immersed in that shadow and at greatest eclipse, when Paige and I are coming back on, I'm really hoping that we are going to see one of the darkest lunar eclipses, darkest red in other words, that I've ever seen. But there are other factors that affect that as well. It's not just how deep it goes into that umbral shadow, and don't forget, the closer to the center you are, the more extreme the red light is that's been bent, refracted by Earth's atmosphere, because that's what's really happening. And we had a lovely little animation earlier that if you were an astronaut standing on the moon, what you'd see around the Earth is this red halo, kind of a worldwide sunset. That's what it really would look like, because you'd be witnessing a total solar eclipse if you were on the moon tonight. Isn't it? What do you lot think out there? Isn't it criminal that we haven't set foot on the moon for so long? There are several generations out there that don't know the excitement of seeing something like a Saturn V rocket going up and being woken up in the middle of the night by your parents to say, come downstairs, you've got to watch TV. How many times has that happened in your life? Your parents tell you, you've got to watch TV. Well, it happened to me. And I remember I was brought downstairs at a very early age, probably before I really realized what was happening. But I do remember it. And seeing, mankind put a foot on this orb that we're watching tonight. So it's criminal, isn't it? Anyway, by the way, we also want to hear from you. If you've got questions for me, our other host, Slooh astronomer Dr. Paige Godfrey, Slooh storyteller Helen Avery, who we heard from a little bit earlier, just use the hashtag Slooh, and we'll get to that on Facebook or Twitter. Or just let us know where you're viewing from, because in fact, let me do this, because I did see that we always call Slooh a global community. But tonight the proof is in the pudding, because we got some actually what look like it's probably not exotic for the people who live there, but exotic places for me, certainly. We've got viewers on Facebook who are saying they're watching from Zambia, Aruba, Pakistan, Mongolia, Macedonia, Morocco, and of course Australia. Now those people in Australia, it's well into the night, and actually we lose the moon. We will lose the moon because it's going to be setting, because it's going to be dawn in Australia. But those feeds that we've got further west will be there for the duration. And actually the furthest west feeds we've got are from Slooh's Canary Islands Observatory, which is at the Institute of Astrophysics of the Canary Islands. So these are all the telescopes that Slooh members get to control every night. So those are going to come on, because we're going to see from the Canary Islands moon rise, but the moon is going to be fully eclipsed as it rises. So this is the shot that we're looking forward to. So we're going to see a great big shadow of the volcano of Mount Teide casting over the island, then casting over the Atlantic Ocean, then pointing out towards the far horizon. And because the shadow is being cast by the sun back there, we know that if the sun's setting behind us, the moon's going to rise right in front of us. That big pointy thing is going to be like one huge arrow pointing towards the eclipsed moon as it rises above the Canary Islands. And actually there we just saw, I don't know if you saw it, it clicked in at the bottom of the image. We just saw the start of Mount Teide's shadow just start going over the huge volcanic caldera there. So these are views as well that we keep a really close eye on, and I'm going to come back on later on and make sure that we are on air so that we can be watching the moon, the eclipsed moon rising at the Canary Islands. But anyway, listen, what else have we got to deal with in this particular segment? Extreme, the nice view. So this is from, right, so this is from the Sharjah Center for Astronomy and Space Sciences in the Emirate of Sharjah in the United Arab Emirates in the Middle East, if you don't know where that is. They are suffering from some clouds, so this is kind of eclipsed in a bit of a different way, isn't it? But that view has been clearing every now and again, and you can see very distinctly how much the moon is being engulfed by Earth's shadow. So we'll keep watch on all of these live feeds because we should start later on some colour. You'll be able to see it a lot better than I am because hopefully you've blown us up and you're watching it full screen. I'm only seeing it on a tiny little thing next to me. So if you do spot some colour, let's see who the first person to spot some colour is and check it on Twitter or Facebook, and we'll see who's the first one to see it or not see it. I'm going to keep a very close eye. Anyway, listen, I've got to concentrate on what I meant to be telling you lot, aren't I, rather than looking at these fabulous images. Right, let's see what we're going to deal with. So what have we got coming up? So 24 minutes past the hour. Do excuse me 1 second. I'm just going to catch up a little bit here. Yeah, so the other point that I was going to make was that although we have started this umbral phase where it is that the moon is passing in to this dense inner circle of the shadow, it's not yet a total lunar eclipse. That only occurs, in fact, we'll go back to our lovely diagram, in fact, just to muck the studio around a bit. It's when the entire moon's disk is engulfed by that umbral shadow, that dark shadow. And that's when the color really starts to ramp up. So when it's kind of between the red moon that you're seeing there in the center and the right, just imagine so the moon in this diagram is moving from right to left. When the entirety of the moon is within that inner circle, that inner gray circle, that is when we can call it a total lunar eclipse. And that's why this one is a very long total lunar eclipse as well, because you can see it's almost passing through the very center, so the longest distance to take. But what we'll see then is we will definitely see color by the time that last edge has been engulfed by the umbral shadow, but it will then increase in intensity. So our feed partners will have to carry on adjusting their cameras because it actually darkens. The moon gets darker and darker because less and less light is hitting it. But the light that is hitting it is redder. It's a pure red wavelength of light that's managing to reach listen, at the point when we can greatest eclipse. Before then, everything starts happening in reverse. But we're going to be with you until the end, so there's plenty to look forward to. So anyway, that's it. So it's not, in fact, when is it? It's about 50 minutes time, something like that. Let's take a look, actually. I just want to take a look at our timing. So the start of total lunar eclipse actually is about 50 minutes from now. So, but don't worry, because we'll be back on air to cover all of these key points. Anyway, listen, we want to ask for your support as well here at Slooh, because our mission is to teach the world to explore space. And our Slooh members, they do that every night. And they pay a very low subscription to be able to control the telescope. So if you're enjoying this kind of thing and you want to do it a little bit more, then please consider joining Slooh as either an apprentice or astronomer member, because you support our mission to teach the world to explore space. And you get to watch live views of the sun, the moon, all of the planets. In fact, the page is going to be talking about Mars, because Mars, the red planet, which is going to be fighting in the sky against the red moon tonight for supremacy. It was the opposition of Mars last night. So we're hoping to get some great images coming from the Chile observatory, because Slooh has two missions, so two observatories. But anyway, you'll get to see the sun because we have a special, highly specialized solar telescope at our Canary Islands observatory, which you can watch that during the day. through special hydrogen alpha filters that we've got there. But then you can see the moon, you can see the planets, you see galaxies, nebulae, star clusters, constellations, supernovae. There's a great comet as well that Slooh members are watching. So you can watch all of that live, and you get to control the Slooh telescopes as well. And you can also follow our various courses and live casts about astronomy every week, and you get to do it actually. That one of the strongest, and don't worry, best things about Slooh is actually the community of people there, because you don't have to be an expert. Loads of our members come in, they don't want to really learn beyond a certain level, so actually they just love watching the live views, the live color views coming in from the telescopes every night, and snapping images and building up these wonderful collections of astro photographs that they've taken with the Slooh telescopes. But others maybe make larger collections, or maybe start doing their own image processing as well. And then we've also got a small group, actually, it's a medium group of members who actually do some real research and science with the Slooh telescopes. They monitor near-Earth asteroids so that we can pin down their orbits to make sure that they're no threat to Earth, or whether or not they would be a threat to Earth. But also they monitor comets as well, and we've been monitoring one every single night for the last week or so, because comets, I don't know if you know this, they're not kind of static objects. They're prone to violent outbursts. Right? And about a week ago, this particular comet, C2017 S3 Pan-STARRS, which is a bit of a mouthful at the moment, most of us calling it S3 or S3 Pan-STARRS, put on this really good show out of the blue over a period of hours. It kind of blew up in brightness, and its coma, that's its head, got a lot larger, and then suddenly we started seeing these tails coming out from the back of the comet, and we were seeing all of this live. So it has died down now, but this comet is on the way to its closest approach to the sun, which is called perihelion, in a couple of weeks' time. And we think, we're not betting people, but we reckon that this comet is showing all the hallmarks of Comet Ison, if you remember, a few years ago, which was heralded to be one of the great comets, but actually it didn't survive its close encounter with the sun. It blew apart, so we didn't see it as it was passing behind the sun, obviously, because we can't point our telescopes in that direction to see a comet. And when we were expecting to see it come out from the other side of the sun, only a few fragments existed. So we reckon that S3 Pan-STARRS might be going the same way, but before they do that, they normally put on quite a good show. So if you're interested in that kind of stuff, join Slooh, because you get to see it every single night. Now then, let's hop back over here, because I am going to tell you, in fact, let's just have a quick hop through our live feeds at the moment. So I'll go through them as the studio brings them up. Oh, and there you go. Look, there was me looking through my notes. Well, that's when the total lunar eclipse phase started, and there it is on the screen all the time. And we can see it counting down on the left-hand side, 46 minutes. But here we've got one of our feed partners, Jonathan Bradshaw, down at the Samford Valley Observatory in Australia. And we've got some fabulous views from him, and we can see the moon is getting darker and darker and darker. And actually, I'm just, excuse me, because I'm just going to increase this on my screen a little. I don't know about you. Can you start to see any pinkish hue? I think I can, actually, down at the bottom, around the 5 o'clock. Now, is that my eyes? Could well be. These are old eyes. They don't work quite as well as they used to. Or is this the start of the colour that we're expecting to see? So anyway, that's Jonathan Bradshaw. Huge thanks to Jonathan Bradshaw. I spent a month actually on a special project with Jonathan and our other feed partner, actually Keith Kobe, who's in the United, and he's giving us a feed tonight from the deserts of the United Arab Emirates. And we spent a month observing the moon and getting it online. And it was for a particular telephone company, and they wanted to do something really unique for their customers. So they basically had us, and all of their customers could select which moon crater or which moon feature they wanted to have a look at. And we were running for 24 hours a day, because we had me in the Canary Islands, we had Keith Kobe in the United Arab Emirates in the Middle East. We had Jonathan Bradshaw in Australia, and we also have another partner as well over on the west coast of America. And it was an absolutely extraordinary and very hard work. We were kind of working 18, 20 hours a day for a month, but it was, put it this way, it was a bit of a bonding experience for Keith, Jonathan and myself. But anyway, let's take a look at our other feeds at the moment. Even if the studio can bring up the other feeds, even if they're clouded out. So we take a look maybe at the Sharjah Center for Astronomy and Science, how are they doing at the moment? So there we go. So, you know, we're seeing roughly the same level of shading on each one. So what these guys might choose to do very shortly is not worry so much about adjusting their cameras to get that still partially illuminated side of the moon. They might want to turn up their exposure. That might get a bit blown out, but what we then might see is this red light, which is hitting the darkened area. So who knows, they might start doing that. So that's that one. I think I'm going to be hopping off because I think I'm going to work with Keith, make sure that we can get his feed up as well. And don't forget, later on, as I say, the Slooh telescopes are going to come back online as well to watch moon rise. I'm really looking forward to that because it's something that we haven't seen before. And it's actually, I will just spend, I think I've got a couple of minutes. Yeah, I got a couple of minutes before Paige is coming back on. Around the world, you might be asking yourselves, can I see this for myself in my own skies? Well, the studio will bring up this handy little map that we've got. And basically, if you're in any of the dark area that you'll see on this little map, you will be able to see the lunar eclipse at some point. So it might be, for Jonathan in Australia, it's at the end of the night. For the people in the Far East, so here we go. So now watch this. As night progresses, Jonathan's on the east coast of Australia there. So bang, there it is. So halfway through the total phase of this eclipse, the moon is actually setting in Australia. So we're going to lose Jonathan kind of halfway through, but he's hoping to be able to point his telescope almost down to the horizon before it disappears. But you can see that any area, and also if you, when it starts getting, look, so there we go, Middle East, India, Africa, Middle East, they see the beginning of the eclipse, the moon is up in the sky, all the way through, there's the total phase ending, and they see it all the way through the end. So India just gets to see it before moon set there. But now look on the west coast of Africa, because that's where the Canary Islands are. Bang! That's when we start to be able to see the moon rising. And as you saw, the moon was eclipsed as it's rising. So that's why, you know, in different places, you'll be able to sometimes see the moon, but some people will see all of the eclipse phases. Others will only see it at moon set or moon rise. Now, if you're in North America, where does this leave you? Now, you can see there, some people in South America managed to just get a little glimpse. So here we go. It's about to become, you know, there you go. So it's sunset there in South America. They just get to see the end. But look, there's the end of the eclipse, and none of those grey areas hit North America. So that, unfortunately, means for you guys over there, and that includes everybody over in the Slooh studio who are operating the show tonight, and the rest of the Slooh crew are actually over in the States. They're not going to be able to see this in their own skies at all. So it's just as well that we're online bringing you these pretty cool feeds. So let's have a look. So I think we'll go through what is coming up next. So I just got to check one little thing. Yeah. So you can carry on in a second when I finish this. Carry on enjoying our live feeds, bit of music, some of those fascinating moon and eclipse factoids. Hey, if you've got any fascinating moon or eclipse factoids that you'd like to share, then post them on Facebook to @Slooh or our Twitter. And we'll try and get them into the show somehow. So if you've got any fascinating moon or eclipse factoids, then let us know. And those come up on the right-hand side of the screen, so make sure you catch some of those. Don't forget to snap and share your own images from our live feeds if you're watching over at slooh.com. But shortly after that, in fact, it's going to be in 10 minutes' time, Dr. Paige Godfrey is going to be returning to the show, and she's going to be explaining this difference between a mini moon. Don't forget, we're at a mini moon tonight, which is the moon, a full moon, when it's at its
lunar eclipse
smallest apparent size in the sky, versus a super moon. And we've got a great graphic there. It's not actually a graphic, it's two images that I took using the Slooh telescopes of a mini moon and a supermoon to compare them, because loads of people, once again, they'll tell you, oh, you can't tell the difference between a mini moon and a supermoon. Well, it is a little bit difficult to tell if you look at it visually, but I'll tell you, you wait to see this comparison and you'll say, yes, that's very clear. Hey, look at that. Jonathan has done exactly what we were talking about, and he's increased his exposure. So we should start. I still think I'm seeing a bit of a pink or peachy type hue, just very slightly maybe down on the bottom. But what we're going to see as this exposure changes, we're going to see that dark portion. That's where the color's really going to start getting rich. So as more and more of the moon disappears, Jonathan and the other feed partners, they'll adjust their exposure, so we start seeing that dark part, because the only light that's hitting that dark part at this very moment is the red light that's being spun around, bent around through Earth's atmosphere, and it points towards the moon. So all the blue light is being scattered off to either side in those penumbral shadow, but all of that red light, which bends more by our atmosphere, which is why we see a sunset and a sunrise, is pointed directly to that. So look at that. There is, so once again, let's set the challenge, shall we, to all of the flat earthers out there in interweb land. Take a look at this image and explain to us how a flat Earth could cause a curved shadow. Now, I'm sure you've got some fanciful explanation, but let's see if you can come up with a decent explanation. I mean, even the Greeks were proving Earth was a globe, a sphere, by using exactly this same technique millennia ago. So flat earthers out there, there's a challenge for you. Try it out. Anyway, what else have we got coming up later on? Dr. Paige Godfrey, she's going to be telling us the difference between mini moons and supermoons at the top of the hour, so only 8 minutes time. And also she's going to be telling us how the moon causes ocean tides. And she's going to be talking about another red celestial object visible all night long this week, the rusty red planet Mars, which was at opposition 13 hours ago. That was its closest and biggest to Earth. So it really looks spectacular through the telescopes. And we have scheduled for the next 2 nights, we've scheduled the 2 telescopes, that we've scheduled every 20 minutes Mars missions using both observatories, our Chile Observatory and our flagship observatory at the Institute of Astrophysics of the Canary Islands, to show you Mars. And actually, what we land up doing, Mars's day, how quickly it spins on its axis, is only, I think, about 30 minutes longer than Earth's day. So the fact that we can observe it all night long, because it rises as the sun sets, just like our full moon tonight. Hey, did you see that in the live image stream? Another chunk of the moon was just taken out. But Mars rises at opposition as the sun sets, and it sets in the west as the sun rises in the east. So basically we get to see a planet at opposition, just like a full moon, all night long. Now, in the case of Chile at the moment, our nights are about 11.5 hours long. That's when the telescopes down there are operating. So this means that actually we're going to see 46% of Mars's surface, because we're going to be watching it roll. And we did look last night, and we can actually see some of the Martian features as well. So Paige is going to tell us all about that. Then I'm going to be back at 1/2 the hour when we take in the all-important beginning of the total lunar eclipse. That's at 3:30 p.m. Eastern time. That's 19:30, so in half an hour's time, basically. And then at the end of that segment, we're going to be able to watch the eclipsed moon rising at Slooh's flagship observatory in the Canary Islands. And hopefully Helen Avery will join me for that, because she's also going to be doing the next segment of her stuff as well. So that's plenty to look forward to. I better make way for Slooh astronomer Paige Godfrey, Dr. Paige Godfrey. But now sit back and relax with the live feeds, music, few more fascinating factoids about the eclipse and our magical moon tonight, you really must not go anywhere, because we're really entering now, you know, the start of what could start to be, you know, a really good color setting in on this total lunar eclipse, the longest of this century. Now, make sure you watch over at Slooh in what we call the Situation Room, where you're going to be able to snap your own pictures from the live streams as they come online. Anyway, Dr. Paige Godfrey will be back here in 5 minutes' time. Bye for now. Scheduled to move this meet.
Welcome back, everyone. You are watching the total lunar eclipse with, sorry, my that was my feed. My phone just fell over, so my feed went sideways. Fine. Okay, so you're watching the total lunar eclipse with Slooh. I'm Dr. Paige Godfrey, and I'm coming back on to talk to you now about the science behind lunar eclipses and why the moon has phases. What does that do to our tides? What is this deal with a mini moon we're talking about? So you're looking at a live view right now from Australia of the total lunar eclipse, and look at that light. It is beautiful. The moon is starting to be eclipsed. You can see on the left-hand side, we're getting that reddish color. That's the blood moon. That's where that comes from. So the moon can take on like a peachy, pink, reddish hue as it enters its umbral phase, because the light from the sun is going through Earth's atmosphere and bending around the Earth. And so what we see reflected from the moon is this light that has been angled upon reflectivity, and then also it has been scattered through our atmosphere. So if you're familiar with a sunset, our sky is blue during the day when the sun is overhead, because blue light scatters more efficiently than red light. So the blue light gets scattered all over. But then as the sun starts to set, its light has to go through more atmosphere to reach us. Then the blue light is all scattered away, and you're left with just the red light with the longer wavelength. And so you're seeing this happen here, that the sunlight is going through a bunch of atmosphere and being bent. And so we're getting this red glow coming off of the moon. I was just told by our studio that is watching social on Facebook, people from Australia are saying that they're seeing this view from their backyard. I am so jealous. I am in New Jersey. We don't have a view of this at all. And I actually just lost the sun because it looks like it's going to rain. So I don't even have a sunny day anymore. So I'm very jealous of everyone that's getting this view in Australia, but very thankful that they're sharing our feed with us and we're able to see it. So let's start with a question from Twitter. Kitty Bennington said, my 6-year-old daughter, Riley, dreams to be an astronaut someday. And she asked, what calculations go into predicting eclipses? Now, I'll be honest, when I read this question at first, my initial thought was, I have no idea. I don't know how to answer this. But basically, there's two parts to calculating eclipses. The first is to figure out when it's going to happen. And then from there, you can determine where it will be visible on Earth. So this requires a lot of observations over time and calculations of the position of the moon and the sun, right? Because we need both in order for an eclipse to happen.